Hi, I would like to thank Victor and Lotte for allowing me to post this video. I would have loved to come to this wonderful event, but other commitments prevent me from doing so. The Anthropology of Concrete, or Concrete Anthropology. So the title of my presentation is Concrete Paradoxes of the Anthropocene. Due to major mistakes in the past decennial census of 2012, which resulted in more than 10% of all households not being recorded, the Chilean government decided last April to run an abridged version in advance of the standard census plan for 2014. The first question that all Chileans censed had to respond during the interview inquired about the materials in which households are built. Leading the list was reinforced concrete, followed by traditional materials, including in the following order: brick, wood, and adobe. At the bottom of the list, the option precarious materials was included, exemplified by tin, cardboard, and plastic. All materials found often around illegal settlements. Unlike traditional and precarious materials, concrete had been portrayed nationally in an instant as the most universally desirable building material. Such view of concrete often becomes vivid when people in rural areas outside Santiago use the expression building with materials, with the word material referring exclusively to concrete. Brick, wood, or adobe, abundant in many regions outside the capital, are seen, despite their heterogeneous environmental advantages, as less permanent and more precarious. In the eyes of most Chileans, only the hard and solid is meant to last. Concrete's preference is unsurprising given how the discovery and use of the material entangles intimately with the quick spread of modern narratives of progress, built around a final transcendence of traditional values and customs through a rational control of nature. River dams, skyscrapers, transoceanic channels, roads, among other engineered structures, are but examples of how concrete, since its rediscovery in modern times, has allowed humanity to defy environmental forces and connect the world. Currently, unlike most other industrial materials, concrete's production and consumption correlates almost perfectly with economic growth. Led at the start of the Industrial Revolution by powerful economies in the Northern Hemisphere, particularly in Europe and the US, and followed only recently by overtaking economies such as China and India, concrete quickly turned into an iconic marker of national development. Leading countries in Latin America have done their best to catch up with this global trend in their efforts to achieve economic growth. In particular, Chile, a country relatively successful within the region, the trend entangles with the particularities of its geography. Concrete became quickly adopted as a standard in construction after large urban areas were devastated by major earthquakes at the turn of the last century, which had started to precariously densify, attracting people from rural areas in the hope for better opportunities. Currently, concrete is the second most highly produced material in human history, only after water. With more than half of the world's population living in urban environments, concrete is undeniably the most common building material surrounding humans. Encountered often in already casted orthogonal forms dominated by concrete's smooth and opaque surfaces, concrete has facilitated an illusion of lasting solidity that corresponds with the image of solidity modernity has attempted to build for itself in its efforts to transcend nature once and for all. The very gestures involved in the troweling of concrete form suggested. Claiming the present, they trowel to smooth out the very gestures that give shape to concrete forms, pretending as if surfaces had not co-emerged with the movements performed by those crafting them. Such built environments had literally lifted modern lifestyles above the ground, suffocating the exchange of matter and energy between the earth and sky, on which the flourishing of life on the planet has ultimately depended. Yet humanity is becoming aware that this suffocation is contributing to threaten its survival on this planet. Concrete has not only provided a solid infrastructure for modern values to disseminate around the world. Moreover, concrete is a silent contributor of CO2 in that cement production alone accounts for between 5 and 10% of global carbon emissions. Concrete's preeminence in the built environment undeniably turns it into a suitable candidate to mark the start of the Anthropocene, term proposed recently by the scientific community for the current geological epoch to describe humans as the leading geological force. Take the surface of the built environment, such as those that compose the landscape of Santiago, similar vast examples of which are scattered all around the world. Let's add it to all the surfaces of the planet that have been intervened in the sourcing of concrete ingredients, extracted mainly through the removal of sand and aggregate, as well as the mining of limestone. The industry around concrete building has been producing one of the most, if not the most, distinctive markers identifiable across the globe to signal the start of the Anthropocene. Unlike other potential markers, such as those resulting from nuclear detonations, concrete surfaces have the potential to provide a distinctive clue as to how nations should assign responsibility for the environmental crisis, bearing in mind that although we might all be in the Anthropocene, not everyone has been participating in the same way. The global distribution of concrete will most certainly highlight the global north as the leading contributor to global warming. Despite its obvious preeminence in defining the Anthropocene, only a limited number of people have had the opportunity to mix concrete, with the result that most are unaware of concrete's basic ingredients and the stories that compose their trajectories. Moreover, only a handful of people, mostly related to the science and engineering sector, are aware of the impact concrete has on global warming. Indeed, discussions around the issue are not common in many relevant academic circles that are directly involved in perpetuating concrete's widespread use. An example is in Etienne Turpin's recently published edited volume, entitled Architecture in the Anthropocene. It's 250 pages holding 26 different contributions make not a single reference to concrete's environmental impact. This is consistent with how the vast majority of the architects I have spoken to and interviewed since 2013, as I started to work with concrete, have confessed being unaware of concrete's environmental impact. From the viewpoint of the majority of the Western population, this is unsurprising, bearing in mind how the CO2 released by cement factories, including those found only a few kilometers away from Santiago, is an inodorous and transparent gas that remains invisible to the senses. Perhaps the most iconic material of modern life in the Anthropocene, concrete is a familiar stranger of our own epoch. Interestingly, other entities have been described as familiar strangers in the Western tradition. Key examples are time and the soul, the former traditionally regarded by many philosophers as a property introduced by the latter into the world. Regarding time, St. Augustine claimed inaugurating its study in the Christian philosophical tradition, that although we rely on time at all times to orientate ourselves in life, it is perhaps the hardest phenomena for us to understand. Regarding the self, similar has been argued, for instance, by Nietzsche, when he famously suggested that, and I quote, "We are for ourselves what remains farthest to our comprehension." Time and the soul, unlike space and body, respectively material and ethereal, extensional and intentional, have remained partially occluded, and that they are both beyond quantification. The correspondence between time, the self, and concrete is fitting, in that concrete, the material of our times, operates as some sort of alter ego of modernity, reflecting its utopias and dystopias. The latter, bearing in mind how concrete sits literally between nature and culture, and that the tendency in the West has been to map the separation between matter and meaning, mind and body, on that between earth and sky. Concrete will sit somehow in between a buried nature below and an atmosphere above, just like the way modernity narrates its trajectory as an evolution not only in, but more precisely out of nature into culture. Two more entangled oxymoronic understandings of concrete reflect this condition, mirroring the paradoxical place modernity has built for itself in Earth history. Since its modern rediscovery in Victorian times, concrete has been regarded by the industry as an artificial stone. Yet at the same time, since its earlier origins in Roman volcanic activity, concrete has been described also as a solid fluid. Laboratories dedicated to the development of new concrete formulas are sites par excellence where these oxymoronic descriptions of concrete are defined and contested. Yet, unlike classical understandings of concrete, such as that reflected in the first descriptions left by Roman authors, such as Vitruvius or Pliny the Elder, the tendency in modern science and engineering has been to emphasize one side within these paradoxical understandings, namely the one that most strongly align with narratives suggesting a solid departure of modernity from nature. As an expert explained while introducing me to the work regularly undertaken inside a concrete lab, the goal is to, and I quote, produce an artificial stone capable of enduring time, end of quote. Stretching the life of concrete through increased strength is what implicitly guides research inside laboratories, often having an ideal of eternal life implicitly as a background. As it occurs with the modern drive to extend human life, eternity is not a mere fictional expectation, but surfaces every so often in the demands of users. An example is in the concrete Baha'i temple finished recently in Santiago, the requirements of which had to be dealt by Francisco, an engineer working at the lab, at Cemento Melon Lab, the oldest cement factory in the country. As Francisco explained to me in our first encounter, the expectation placed on the company by investors was for concrete to last literally 500 years. Jokingly, he mentioned having no trouble in signing a document confirming the request. After all, he will be long gone by then. In a lab's daily practice, detailed measurements of ingredients of new formulas are carefully recorded. Each new mix tested for its fluidity. And once cured, in standardized molds, engineers measure the compressive quality, flexibility, deformation, and permeability of formulas. The history of the formalization of mixes since Joseph Aspiding's first recipe was patented holds a tendency towards a progressive reduction of heterogeneity, a tendency going all the way from the mining of ingredients to their measured agglomerations. Carefully aligned with that trend, each trial and error in a lab is measured against those first formulas in genealogical correspondence, as if innovations could be described evolutionarily as a divergence from an original ancestor. As a Chilean PhD student conducting research on concrete explained to me, Chilean researchers wanting to internationalize their research by publishing in English journals, or journals written in English, have to necessarily conduct their research in reference to Portland. A globalized tendency applying even to green formulas designed to counteract the effects of cement production. I mean, the environmental effects of cement production. The latter, despite that in Chile, unlike the UK, where Portland was originally patented, almost all the concretes include a high percentage of fly ash, which companies extract from areas where there has been volcanic activity. Despite all this rationalization, entangled in genealogies of global power aim at extending the solidity of the infrastructure on which modern hopes are built, hybrid images continuously proliferate in labs. Coexisting with the promise of eternal durability, engineers become aware time after time that no matter the effort, nothing can set time still for concrete. Progressively worried about the environmental impact of cement and the targets to reduce carbon emissions, many engineers are worried about what is often described as the, and I quote, pathologies of concrete, particularly the cancer that occurs in concrete forms each time it cracks, allowing water to infiltrate rusting reinforcements. These pathogenic images of concrete destruction correspond with how engineers speak of curing as a process of growth, where molecules align forming capillary structures. The image relates also to how soil scientists envision nowadays the emergence of soil and the continuation of life in urban environments through the crumbling of concrete, in what they describe or call nowadays aerosols. These organic notions share a striking resemblance with a long tradition relating body and earth going back to the great grandfathers of geology. I'm thinking of Nicholas Steno, credited for first formulating the principle of superposition on which our understanding of Earth history rests, and according to which deposits tend to align vertically in upward gravitational accumulation. Originally trained as an anatomist, Steno found himself only by chance looking at the history of Tuscany after the Duke of Livorno commissioned him to inspect the head of a gigantic shark found in the Mediterranean, the teeth of which resemble distinctive fossils from the area. Interestingly, Steno, just like the engineers imagining the growth of concrete, described the Earth as having a capillary structure interposed by cavities, canals, and tendons, an appropriate image bearing in mind the deep history our bodies share with cement. Resulting from the burning of limestone, a mineral made of fossilized shells, cement makes the urban landscape look like a man-made reef, the trajectories of which can be traced all the way back in deep time to the rich calcification of the Cambrian seas, where bodies became mineralized, giving birth to both the skeletons and the shells of vertebrates and gastropods. In such organic image of what constitutes Earth history, mirrored on the growth of bodies, no room for fixed ground set against a fluid atmosphere is possible. In continuous exchange, the ground turns into a solid fluid, constantly growing over. Thank you.